Let's look at a couple examples of verifying identities using our fundamental identities. So remember again, the fundamental identities include the reciprocal and the quotient identities, the Pythagorean and the even odd identities, and then the complementary and supplementary identities. Okay. Also remember when we are dealing with identities, we can't treat the identity that we're given as an equation. So that means you can't add or subtract something to both sides of the equation. You can't multiply or divide something to both sides of the equation. You can't take the square root of both sides of the equation, right? You can't do something to both sides of the equation as sort of a balancing effect, right? Instead, we have to treat each side of the equation, each side of the equal sign, as its own independent expression, and we need to simplify each of those expressions to match the other. So we could take the left side and rewrite the left side of the equation all the way so that we eventually get to the point where the left side of the equation has been rewritten to look like the right side of the equation. Or we could do the same thing with the right side, just do a bunch of steps of simplifying to make sure that the right side matches the left side. Or you can kind of work both, where you do some steps on the left, you do some steps on the right. We're not crossing the equal sign, but we do a little bit of work on each side to that we get to the point where they match together. Okay, so there's a couple different ways you can approach that. So let's look through just at a couple examples here. And the process, kind of each step should be the same as when we are simplifying identities. Every step you should be asking, is there an identity I can use, or is there algebra I can do? Okay. But again, remember, our goal is not to completely simplify the expression, it's to make it look like the other side. Okay. So in this first example, we have the cosine of theta divided by the quantity 1 plus sine of theta. We want to show that that is equal to the secant of theta minus the tangent of theta. Right now, it doesn't really look like there's any algebra I can do. Okay, I have a 1 plus a sine. Those are not like terms. I have a cosine over a 1 plus sine. I can't really divide that out. And then I have a secant minus a tangent, which, again, those are not like terms. I can't add them. Okay, so let's try to do something with an identity. Right now, really the only identities I'm seeing is that I know secant and tangent both have a reciprocal or a quotient identity that we can use. So let's try to take the right side and rewrite it to match the left side. Okay, so if we take that secant of theta using our reciprocal identity, I know secant of theta is 1 over a cosine of theta. And I know tangent is sine of theta over cosine of theta. Okay, so I have 1 over cosine minus sine over cosine. Is there algebra I can do, or an identity I can use? Well, I have two fractions with a common denominator, so I could go ahead and combine them. So let's do some algebra. When you subtract fractions, you subtract the numerator. So we're going to get 1 minus sine of theta. And all of that is over the common denominator of a cosine of theta. Okay. Now, again, I look at what I have here, 1 minus sine of theta over cosine of theta, and I'm trying to match that with cosine of theta over 1 plus sine of theta. Okay, so how do we make that connection? Okay, well, one thing that we can consider, since everything is in terms of sines and cosines, think about our Pythagorean identity. I know I have sine squared theta plus cosine squared theta is equal to 1. And if I subtract the sine of theta, or sine squared theta, from both sides of our identity, the Pythagorean identity, then that leaves me with cosine squared theta is equal to 1 minus the sine squared theta. And if you look at that 1 minus sine squared theta, that is close to what we have here in the numerator. We have 1 minus sine theta, not sine squared. Okay. And I know that if it was 1 minus sine squared, I could replace it with a cosine squared. And if you look on the left side, we do have a cosine in the numerator. It's not squared, but we do have a cosine. So how can we convert a 1 minus sine to a 1 minus sine squared? Well, 1 minus sine squared is actually just the difference of two squares. And so that means 1 minus sine squared is actually the same, or it can be factored as 1 minus sine of theta times 1 plus the sine of theta. So we can do a little factoring. 1 minus sine squared is the same as 1 minus sine of theta times the quantity 1 plus sine of theta. And if we look at that, there's my 1 minus sine theta. So in order to go from a 1 minus sine of theta to a 1 minus sine squared, I need to multiply by a 1 plus sine of theta. So I'm going to go ahead and do that to my fraction here. So I have 1 minus sine theta over cosine of theta times, so I need to multiply a 1 plus sine theta in the numerator. Well, whatever I do in the numerator, I also have to do in the denominator. So just like we're finding a common denominator. So I'm going to multiply 1 minus sine theta over cosine theta times a 1. That 1 is going to look like a 1 plus sine theta over a 1 plus sine theta. Okay. When I do that in the numerator, we have to FOIL. So the 1 minus sine theta times the 1 plus sine theta. But we kind of did that with our identity. I know that that's going to give me a 1 minus a sine squared theta in the numerator. And in the denominator, I could go ahead and multiply, well, I have to multiply the cosine of theta times the 1 plus sine theta. I could go ahead and distribute that and do the actual multiplication. Or I could just write it and leave it there. So I'm going to do that this time. I'm just going to write cosine of theta times the quantity 1 plus sine of theta. Okay. Why am I not multiplying that? Look at the left side. In the left side of our fraction, we have cosine of theta over a 1 plus sine of theta. Well, here is that 1 plus sine theta. So it's already there in my denominator now. I don't want to mix it up with the cosine, so I'm going to leave that cosine out front of the parentheses. Okay. If you did multiply the cosine through, you're just going to have to factor it back out later. So sometimes it's helpful to write what the multiplications are before you actually do the multiplications. All right, so how do I go from here? So we have 1 minus sine squared over the quantity of cosine times the quantity 1 plus sine theta. Well, what we saw in our Pythagorean identity up here was that cosine squared of theta is equal to 1 minus sine squared. So I can rewrite the numerator of this 1 minus sine squared, as a cosine squared theta. And that's all over the denominator cosine theta times the quantity 1 plus sine of theta. And we are almost done. So what algebra can we do? In the numerator, I have a cosine squared, which is cosine times cosine. In the denominator, I have another cosine. So one of the cosines out of the cosine squared is going to cancel with the cosine in the denominator. And so that's going to leave me with a cosine of theta in the numerator divided by a 1 plus sine of theta in the denominator. And if you look at that, cosine of theta over 1 plus sine of theta, that matches what the left side of our identity was, cosine of theta over 1 plus sine of theta. So we have just shown that secant theta minus tangent theta is actually the same thing. It's actually equal or equivalent to cosine of theta over 1 plus sine of theta. And so that verifies the identity. Okay. All right, let's try a second example here. We have cotangent squared of x divided by the quantity cosecant of x minus 1. And that needs to be equal to the quantity sine x plus 1 divided by a sine x. The process is going to stay the same. We need to think about, is there any algebra I can do? Is there an identity I can use? Okay. Right now, there's no like terms. There's no common denominators we can use. There's not a whole lot that we can do in terms of algebra. If we think about identities, so do we have a way to rewrite cotangent in terms of cosecant, or maybe cotangent or cosecant in terms of sines and cosines? And yes to all of those. There are different ways that we can do that. Okay. So some of our options might be that we have the Pythagorean identity that 1 plus the cotangent squared x is equal to a cosecant squared x. So that's one option. We also know that cotangent of x is equal to cosine x over sine x. So that's another option. Okay. We know that cotangent x is equal to 1 over tangent of x. Okay. I'm probably not going to be too interested in that one, though, because that's going to introduce tangent into an expression, into an equation that has no tangents in it. May not be a bad thing, but that's probably the one I'm feeling the least likely to go with. What about cosecant? We already have a relationship that cosecant is related to cotangent. We also know that cosecant x would be equal to 1 over sine x. Okay, so we have several possibilities here that might be helpful. Okay, so the question just becomes, what do we want to use? Okay, let's go with, for now, let's try to go with two of these. Let's use the identity that cotangent of x is cosine over sine, and the identity that cosecant is 1 over sine. Okay, so I'm going to take the left side of the equation. We're going to take that cotangent squared x over the cosecant of x minus 1, and I'm going to rewrite that using those two identities so that everything is in terms of just sines and cosines. Okay, again, this may not be the right way to go, but it gives us something to try. And so many of these problems is just really try something. Pick an identity, use it, see what happens. Do some algebra, see what happens. If it helps or seems to be helping, take it a couple steps, see where it goes. If you go a couple steps and it looks like the problem's exploding in your face, go back and try something else, right? Don't get bogged down into trying something and it makes a mistake, or don't freeze up because you're not sure what to do. Just try something. So if I have cotangent squared, cotangent is cosine over sine, so cotangent squared is going to be cosine squared over sine squared. And then in the denominator, cosecant x minus 1 is going to become 1 over sine x, and then minus 1. Okay. So that may look like it just got worse. We went from having one fraction to now having two fractions together. But again, just because it gets a little worse right now doesn't mean it's worse overall. Look into just the denominator. In the denominator here, we have 1 minus sine x minus a 1. And think of that 1 as being over 1. The algebra that we could do here is to combine the 1 over sine fraction with the whole number 1. To do that, we need to rewrite it using a common denominator. So the numerator itself hasn't changed. It's still cosine squared over sine squared. I'm going to rewrite the denominator as 1 over sine x minus, and I'm going to replace the 1 with a sine x over a sine x. And again, if we look in the denominator here, I now have two fractions that I'm trying to combine, and they have a common denominator. So let's go ahead and do that. Numerator is still cosine squared x over sine squared x. The denominator is going to become the quantity 1 minus sine x all over a sine x. Well, I don't know if does that feel like it's gotten any better? Maybe. So we've combined two terms in the denominator into now one term. We're also taking one fraction and dividing it by another fraction. So how do you divide fractions? You take the denominator, you flip it, doing the reciprocal, and then you multiply, right? So this I could rewrite. Again, the original denominator stays the way it is. So we're going to have cosine squared x over sine squared x times, we're going to take the denominator fraction and flip it and multiply. So it was 1 minus sine x over sine x. Now it's going to be sine x over 1 minus sine x. Okay? And if you look at here, right now I have a single sine in the numerator, and I have a sine squared in the denominator. Well, sine squared is really sine times sine. So the second sign is going to cancel, and the second sign in the denominator is going to cancel with the sign in the numerator. Okay, and so we can go ahead and I'm going to come up here for space. We can go ahead and sort of multiply those, but I'm not going to actually distribute stuff. In the numerator, we have a cosine squared x times a 1, right, because we canceled the sign. So that just leaves me with a cosine squared. And in the denominator, I'm going to have a sine x times the quantity 1 minus sine x. Okay, so again, remember, as we're going through this whole problem, we need to be thinking about how not to simplify it completely, but to make it match the other side. So we started with the cotangent squared, the left side of the equation. When I'm done, I want to be able to simplify all this to be sine x plus 1 over sine x. Okay, so looking at what I have right now, I have cosine squared x over a sine x and a 1 minus sine x. I already have the sine x in the denominator, so I don't want to do anything to that. I need to get rid of the 1 minus sine x, though. Okay. Well, we have another identity. Remember our Pythagorean identity. We've already done this, I think, in previous examples, but sine squared plus cosine squared has to equal 1, which means cosine squared is going to be 1 minus sine squared. So I can take the numerator of my fraction, which is a cosine squared, and I can replace cosine squared with a 1 minus sine squared. So I have 1 minus sine squared over sine x times the quantity 1 minus sine x. How do we simplify that? Well, you might be tempted just to cancel the 1 minus sine squared with the 1 minus sine, because they look very, very similar. But remember, 1 minus sine squared is actually a difference of 2 squares. We need to factor that first. So I can take 1 minus sine squared and factor it as 1 plus sine x times the quantity 1 minus sine x. And that's still all over sine x times a 1 minus sine x. And again, the idea with difference of 2 squares, if you just had x squared minus y squared, that's equal to x plus y times the quantity x minus y. So that's how we're factoring the difference of 2 squares. Okay, so that's how I went from 1 minus sine squared, because the 1 is technically a 1 squared. So 1 squared minus sine squared, it becomes 1 plus sine times 1 minus sine. Okay, so I have 1 plus sine x times 1 minus sine x all over sine x times that 1 minus sine x. Well, the 1 minus sine x is canceled, and that leaves me with 1 plus a sine x over a sine x. The order of addition doesn't matter, so I could flip those around and say I have sine x plus 1 over sine x, and that matches what we had on the right side of our original identity. Okay, so that verifies that cotangent squared of x divided by the quantity cosecant of x minus 1 is actually always equal to sine x plus 1 divided by sine x.